All right, here we go. We are going to finish up 5.2. So let's just do a little bit right here. Then I'm going to switch to that other program. So let's do this. Let's go to the polygon tool. Click on. Oops. You're supposed to be if it clicks. There we go. You know what I found out? I was watching my video the other day, and I saw this part. You can't actually see this. See that little thing that says polygon? You can't see that when it records it. It's really weird. So whoever's watching it right now is not even going to know what I'm talking about because you can't see it. So, there we go. All right, so let's just have a triangle, any old triangle. So watch what we're going to do. We talked earlier about how to find the centroid. Remember how to find the centroid from earlier? So we find the what? The midpoint of all three sides. Okay? So let me do this. So the midpoint's probably about right there. Let's just eyeball it. Where do you think the midpoint is on this one? About right there? Yeah. That looks pretty close. And then the midpoint's, I don't know, about right there. We may have to adjust some things because I'm just eyeballing it. But we'll use that other program in a minute, and we'll get it a lot more, what do you call it? Accurate. Very good. All right, so let's do this. Let's change the colors of it. Let's go to yellow. So what I'm going to do is how do I find the centroid? I go from the what? Well, it's not a midpoint. Well, yeah, you're right. You could go from the midpoint to the vertex. It doesn't matter which direction you go. I'm going to go from the vertex to the midpoint. By the way, we have a name for this. I should have said that. And if I remember what it is, there it is. Okay, that yellow line right there, when we go from a vertex to a midpoint, we call that thing the median. Let me make it look like an M. We call it a median. Okay? When you're driving down the highway in that big grassy area in the middle of the road, what's that? It's a median, okay? Because it's in the middle, okay? So this hits the midpoint, so we call that the median. Everybody got that? All right, so now this may not come out exactly right because I might have guessed a little bit wrong on where the midpoint was, but we should be pretty close. So I connect that vertex to that midpoint, and now we'll see if we can get it right. So from that vertex to that midpoint, yeah, we're pretty close. It's off just a tad. It's off a little bit, but it's close enough. If I make that dot big enough, nobody will know, okay? All right, so what is that point right there then? When I connect the medians, or when I draw all the medians to that triangle, this is my centroid, okay? So I won't write it again. I'll just put a little arrow. That's the centroid right there. Now, there's something special about that centroid. I'm not going to give it away just yet. We'll use that other program, GeoGebra, and we will do that. So let's go to GeoGebra. I'm going to make sure we see it on here, so I got to click on that. There we go. All right, so now what I'm going to do is draw a triangle. So let's draw a triangle. Oops. Let's try this again. Let's start here. Let's go here, here, here. What happened there? Oh, goodness. Why is it going so crazy? Let's try it one more time. Let's go from here to here. I probably had to teach a rat on me for you guys being so loud. They're probably seeing what was going on. Okay, so here's a triangle. Let's, I don't know, just make it look a little more. It doesn't matter. It really doesn't make any difference. So what we're going to do is go from a vertex to the midpoint of the other side. So we can actually, I think, we can find the midpoint of the other side. I should have practiced this. I didn't. But I'm pretty sure there's a thing on here that says midpoint. Tell me if you see it. That's distance to a point. I thought for sure this had a thing that said midpoint. Do you see it on here? Distance or length. Angle, bisector, tangent, parallel line. Oh, my goodness, it's one of the first ones. It's right here. It's midpoint. Okay. So watch what I'm going to do. I'm just going to click on this line, and it's going to put a point D. Guess where that is? That's the midpoint. So I'm going to do that to all three sides. So E is a midpoint, and F is a midpoint. Did you notice I clicked here, but it put the midpoint where the midpoint actually was? Okay. So now what I'm going to do is come up here to segment, and I am going to draw from here to the midpoint. So what did I just draw right there? That's a what?
No, that's a median.
It's a median. It's a median. That's right. And then I go from the vertex to the midpoint. That's another median. Now, this should be accurate, okay? Mine was pretty close, but you go from the median, or from the vertex to the midpoint, and look at that. It hits right there, doesn't it? Okay? So what I'm going to do now is I'm going to put a point right there, and I believe, do I right click? No, I think I just click on it, or double click. Oh, there it is right there. That's what I want. Click those A's, and then I can change the name of this. And what are we naming that thing?
Sour Patch.
How about Centroid? Okay. All right, so there's my Centroid right there. Now, just like always, I could take this triangle and move it. All right, and where is the Centroid always going to be on this one? It's always going to be, even if I make it real weird like this, it's always going to be inside. I wouldn't say the middle. It's always going to be inside, right? It's going to be the interior of the triangle. So it doesn't matter if it's a right triangle, an obtuse, or an acute. The centroid's always going to be inside it. Everybody got it? Now, here's what's kind of interesting about that. So we know what the centroid is. We know how to find the centroid. But here's something that's really, really interesting. By the way, before I do that, what if I said that the length of AF was 5 and I asked you to find the length of AC? You hear what I just said? What if I said that AF is 5 and I asked you to find the length of AC? Look at it. Exactly right. Why? Because F is where? It's in the middle. So look, if AF right here is 5, then FC is going to be what? 5. And the whole thing is going to be 10. Does that make sense? And we know that because F is in the middle. It's in the midpoint. We good? Okay. So, I mean, that's pretty easy to understand. The next thing you probably would not have guessed. What we're going to do, we're going to look at from A to the centroid, and then from the centroid to D. Let's just take a guess. There is a relationship. Are they the same from A to the centroid, from the centroid to D? Does it look the same? No. Which one? Oh, look, I can use this. I can't move too far because I'm hooked up to my mic. Okay, but look at this thing right here. See that? And see this bit right here? Do they look like the same? Do you think there's a relationship between this and this? Possibly. There is one. I wouldn't ask you the question if there wasn't, okay? So there is a relationship between, you can guess, yes. Add up to two line segments? No. We're talking about the length of a segment. So we're not talking degrees at all. I'll give you a hint. Go ahead. Exactly right. Okay, exactly right. Look, do you see from the centroid to D? Everybody see that? That's actually half of from A to the centroid. Okay? Or you could look at it this way. From A to the centroid is how much of this bit right here? It's double it. Okay? Or here's what they do in the theorem. I think they make it kind of confusing in the theorem, but what is AC compared to the whole entire median, AD? This really takes some thought. What is it? You got it. It's 2/3. Very good. Okay? So the longer segment, we'll call it the longer segment and the shorter segment. Is that all right? The longer segment is 2/3 of the whole entire thing. Everybody got it? So the long one is twice as big as the shorter one, right? Or you could say the shorter one is what? Twice as big as the longer one. So if the longer one is 2/3 of the whole thing, how much is the shorter one of the whole thing? It's 1/3 of the whole thing. Does that make sense? Okay. So let's check. Let's use this program. And I haven't even tried this yet. I'm just winging it right here. So what if I went from A to the centroid? Because I got to make 2 segments here because it's not going to tell me the length. And then what I'm going to have to do is I'm going to have to get rid of this line right here. Let me get rid of that line. It would be right here. Okay, and then what I'm going to do is go back to this, go to the segment. Now I'm going to go from the centroid to that line right there, okay? And just for the fun of it, let's change the color. We'll make that one red. We'll make this in a different color. We'll make this one green, okay? So I'll just refer to it as the red one and the green one. Everybody good with that? You guys paying attention, right? Haven't lost track yet? Seems like you're starting to. So here we go. I want to see if the green one is twice as big as the red one. Kind of looks like it would be, right? Right? But let's see if it is for sure. So I'm going to come over here to this thing that says distance and length. I'm going to click on this green one, and it says it's 8.8. So, very good. So what do you think, if that's true, right? If this is half of this, what do you think this one's going to be? It's going to be 4.4. Hopefully it is. Let's see if I did it right. And look at that. Lo and behold, it's 4.4. All right, pretty cool, huh? Let's just, for the fun of it, just do the other one. So what I'm going to do now is I'm just going to get rid of those long ones just because I'll keep the centroid right there. Then I'll do little segments from vertex to the centroid and so forth. All right. I'm not going to color code them this time. I'm just going to go from here to here. So let's do this. Let's go from B to the centroid. Right? And then go from the centroid to there. And let's go from E to the centroid. And let's go from the centroid to C. All right? I'm not going to color them, but we'll see what it is. Let's go to distance and length again. Let's click on this. That one's 5.1. So this should be 10.2. Look at that. Okay, look at this one. That's 3.4. So what's this? What should this one be? 6.8. Well, it says 7. Why do you think it says 7? Because the rounding part, because this probably isn't exactly 3.4. All right, there is actually, if I go to the preferences, this little wheel right there, I could change the decimals. So you may think that I'm lying to you, but I'm really not. It's just because of the decimal thing, all right, because of the rounding thing. But that's pretty close, though, to 6.8, isn't it? All right? Does that make sense? Okay. And that's basically what they're going to ask you to do on the centroid. So they could ask you this. Watch. Let's say they, so how do I get rid of that? I think if I just click on it. Cancel. There we go. Oops, didn't want that. Anyway, let's just say we didn't know what these lengths were. Okay, let's say we knew one of them. What if I asked you what the length of if I gave you 5.1 and then I asked you for the length of EC, how would you do that? If I gave you this is 5.1, but I didn't give you this as being 10.2. For some reason I can't erase it.
I don't think that's a tissue.
All right. It's fine. Everybody watching?
Stop.
Nico. So what if this is 5.1? What if I asked you to find the whole entire thing? Rosalind, what did you do? Say that again. No, you wouldn't multiply by 2. I mean, to find this one, you would multiply by 2. But what if you wanted to find the whole entire thing? Right. You would find this first, okay, and then add them together. Or, listen, or you could take this and multiply it by, what do you think? Remember, this is 1/3 of the whole thing. So you could just take this and multiply it by 3, right? Would you agree? Because one of these would go to here, right? From the centroid to there, and then from there to there would be another one. So there's 3 of them, right? So there's 3 of the little ones that make up the whole thing. That's why one of them is 1/3. Does that make sense? Okay? You got it? All right. And the same with the other ones as well. So that's the kind of stuff that they're going to do. I was thinking of, what was I thinking? Oh, what if they give you the whole entire thing? Forget these numbers, okay? Let's just say the whole thing was, let's say 12. Everybody watch this, because this is what they're going to do. This is the trickiest part of the whole thing. You're watching, right? Everybody's watching. What if from A to D was 12? I want you to think. I want everybody thinking. And then I asked you to find both of these separate segments. Get everybody a chance to think first. What if I said the whole thing was 12? AD, the length of AD was 12. All right? And then I asked you to find the red one and the green one. The whole thing is 12. So what would you do? Okay.
You divide by 3, and then that would be
Exactly. So did you hear what he said? Divide by 3. Why would you divide by 3? Because this little one is 1/3 of the whole entire thing, right? So what's the same thing as taking 1/3 of something? It's dividing it by 3, correct? So what's 12 divided by 3? It's 4. So this would be 4, okay, if the whole thing was 12, all right? And what would this one be? This would be 8. That's exactly that, okay? They may, I don't know if they do or not. I don't think they do. Nah, they don't really do this. But they possibly, I don't know, could give this to you in terms of x, right? This might be 2x, this might be 5x or 5x plus 2 or something like that. So you might have to solve for x. But remember, the green one, right, from the vertex to the centroid. Everybody see this? Everybody's looking up here, right? I see the tops of people's heads. I shouldn't see the top of your head. From the vertex to the centroid, okay, is 2/3 of the whole thing, or it's twice as big as this. So if they said that this was like 3x plus 2, right, and this was x, I don't even know if this will work or not, okay? So what you would do is you would say that you would say this is twice as big as x. So if this was 3x plus 2, right, you would write 3x plus 2 equals what? 2 times whatever this is. And if this was x, you put just 2x. See, I lost some of you guys because I'm not writing stuff down. I'm just making you think, all right? So anyway, I really don't. I'm looking at the homeworks, and it doesn't look like they're doing that anyway, so I wouldn't worry too much about that. I think they're just going to put regular numbers in there. I don't know. They might. Anyway, they might. All right. I think that's good. You know what? I think there's one more thing that I might have skipped over a little bit yesterday. It was. Let's do one more thing. We got time, right? 7 minutes? Okay, so let me do one more thing. It's kind of what we did yesterday, but I forgot to talk about it. So let's make an angle. So I'm going to go from here to here, and then I'm going to go from here to, let's say, here. All right? So there's an angle. Remember what we did yesterday? We talked about bisecting the angle. So let's go ahead and do that. I think I have a angle bisector right there. Click on that. So what I'm going to do is I'm going to bisect the angle. All right, so there it is. It gives you that extra stuff. Let's just get rid of this thing. It just kind of gets in the way. It's a little ugly. There it is. Get rid of that. And I'll tell you what we'll do. Instead of having that go all the way through, I'm just going to have it start there. So I am just, actually we need a point on here. And now I'm going to do a segment. I'm going to go from, got to do segment. There we go. Click from here to here. Bear with me. I'm almost ready to do this. Let's get rid of this thing again. Didn't want that. Want to do this. There we go. Get rid of that. We should be good to go. All right. Remember we talked about this? We showed this yesterday, right? If I move this around, what is that GJ? That GJ right there. What is that? It's the, what did it do? It bisected the angle. Very good. It's the angle bisector. Okay, it bisected the angle, which means this angle right here and this angle here are equal. But what happens if I do this? This is the one thing I left out yesterday. So they do have a couple questions with this on here. So watch this. If I put a point right there, everybody watching? If I put a point right there at point K, it doesn't matter really where I put the point on here. I can put it anywhere. Okay, I'd put it right here. But the distance, as long as it's on the angle bisector, this is super important. Everybody watching? Not everybody is. So watch, listen. Shh, 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 shh. Listen, just listen. I didn't ask for... I didn't ask for any comments, just let's listen. If I put a point on the angle bisector, we have a theorem that says this. I can't believe I missed it. We have a theorem that says that point is equidistant to the two sides of the angle. All right? Now, we talked about what the distance is from a point to a line. It's the what kind of a distance? It's the perpendicular distance, right? So if I said, what is the distance from point K to this line GH? It would be the perpendicular distance. So it would go about right here and here. Would you agree? All right, so let's put a perpendicular line from point K to this. Now it's going to make a big old line. It's not going to just make that. So what I'll do is I'll put a point right here, and I want to show you this. I think it's important to do this. Don't lose me. Just watch what I'm doing. So I'm going to put a little segment from there to there, and I'm going to get rid of that big old long line because it's just kind of ugly. All right, so there's that right there. Everybody with me on that? So what does the theorem say? If you have a point that lies on the angle bisector, it's equidistant from the two sides of the angle. So that's one distance. Now I just have to do it again to down here. Okay, so let's do it again. Just bear with me. We got to go to perpendicular line. So I'm going to go hit the K. I'm going to hit this line right here. Boom, there's perpendicular line. Okay, I don't want that big old ugly line. So I'm going to put a point right here. Then I'm going to make a line segment that goes from K to M. From K to M. All right, it's overlapping, so it's there. But now I just got to get rid of this. Get rid of that ugly line. And there we go. Now we're ready to show you something. Now watch this.
Are those lines going all the way through, hitting the other point of the triangle coincidence? Or is that...
Yeah, it was just coincidence. Yeah, it's just because of how long I made that thing. Right here now what do you think is true about LK and KM? Let's see if they really are. So I got a way to do that, don't I? Remember that? So if I hit distance, and then I hit this right there, that's 3.1. Guess what this should be if I did it right? This should be 3.1, and there it is. It's 3.1, okay? Now, watch what's really cool about this. What's really cool about, especially this program, is I could take K. It doesn't, remember I said it doesn't matter where on the line it is? Okay, I could move it up there. Now, as I go further away, what happens to that distance? It gets bigger and bigger, doesn't it? If I come down here, but it's still the same though, isn't it? No matter where I put this point, as long as it lies on as long as it lies on the angle bisector, the distance from this point to the sides are going to be exactly the same. Okay? What's that?
Why are the sides moving?
Why aren't they moving?
No, like,
I could move them.
I'm saying, like, when you move it. Like,
When I move it?
Yeah, could you just move that point alone?
That's what I'm doing. Well, it's showing me the distance. It's showing me that distance right there is the same. Okay, so I want it to do this. All right, so if I go like that, that's 1. If I go like that, that's 2, and so forth. But both of them are 2. So here's the whole idea. The theorem says that if you have a point that lies on an angle bisector, it's what? It's equidistant from the sides of the triangle. Do you see what's happening here? Yeah, Trent.
So like, if you add up like L and M, like all
Like this and this? Yeah.
Would it equal like G to K?
No, it has no relationship with that. No. Okay, everybody see that? All right, that's kind of cool, isn't it? That's something I can't do on my other program, so this is kind of neat. All right, you do have a homework assignment. It's on the lesson plan thing I gave you.
Is it Fridays?
It's so I gave you 1 to 12 before, right? Did I give you 1 to 12 already?
No, you gave us 7.
All right.
1 to 7 and...
Everybody's leaving. They're not even listening to it.
You gave us 1 to 7 and 18.
Yeah, let's do Thursday and Friday's homework this weekend. Okay, it's 1 to 12 and then 23 to 37. 1 to 12 and then 23 to 37. 1 to 12, 23 to 37. I don't. Actually, I might have one. Honors. Nope, I don't.
Okay.
But write it down. It's 1 to 12 and 23 to
I
37.
missed a day yesterday, so I have a bunch.
Okay, somebody probably has one. Next period, write it down or something like that. Wait a minute.